In this video, we'll look at several applications of single replacement reactions and the activity series. In a single replacement reaction, an element reacts with a compound to form a new element and a new compound. This reaction type involves oxidation and reduction. A substance that's oxidized loses electrons. That substance is also called a reducing agent. A substance that's reduced gains electrons. That substance is called an oxidizing agent. Each of these reactions is a single replacement reaction. Now stop the video, go to YouTube, and look up sodium reacts with water. After viewing the video, determine the products of this reaction. The answer is, you may have seen the video in which something blows up. This reaction releases heat. The hydrogen then reacts with oxygen in a combustion reaction. That's where you see something blow up. In an earlier video, we said that one property of acids is they react with metals. Stop the video and figure out which metal reacts with hydrochloric acid. And the answer is, use the activity series. A metal reacts with any ion below it on the table. H plus is the acid. So zinc and iron reacts with acid but not copper. So your iron skillet is a good source of iron if you cook your acidic tomato-based spaghetti sauce in that iron skillet. The thermite reaction releases a lot of heat and is used to weld railroad tracks and in underwater welding. Stop the video and predict the products of this reaction. And the answer is, the activity series shows that aluminum is more active than iron. So this reaction will work if you use a metal more active than iron. These aluminum soda cans are made from aluminum ore using the Hall process. Stop the video and answer these two questions. And the answers are, use a metal that is more active than aluminum. So any of these metals will react with aluminum ion to form aluminum metal. The Hall process uses electricity to reduce aluminum ion to aluminum metal. Making aluminum by this process is very energy intensive, so make sure you recycle those aluminum cans. At one time, aluminum was more valuable than gold. Stop the video and answer this question. And the answer is, aluminum is a very active metal and easily loses its electrons to become aluminum oxide. On the other hand, gold is an inactive metal, holds onto its electrons and doesn't become oxidized. In an earlier video, we said that every acid has a conjugate base. Every base has a conjugate acid. We also discussed acid strength. This reaction occurs, which means that HCl is a stronger acid and H2O is a weaker acid. Stop the video and figure out which base is stronger. And the answer is, remember, stronger to weaker when the reaction occurs. For oxidation reduction reactions, this idea of stronger to weaker also applies. So stop the video and figure out which reducing agent is stronger based on these two reactions. Remember, metals are reducing agents, metal ions are oxidizing agents. So the answer is, copper is a stronger reducing agent than silver because that reaction occurs. The second reaction does not occur, which means that silver is a weaker reducing agent than copper. And for the oxidizing agents, note that the second reaction is the reverse of the first reaction. So if a reaction occurs in one direction, it will not occur in the reverse direction. You're doing an experiment to determine the relative activity of three metals, A, M, and Z. Stop the video and answer these questions. And the answers are, this means the first reaction tells us that A is a better reducing agent than Z. In other words, A is more active than Z. The third reaction tells us A is a stronger reducing agent than M. The second reaction does not occur. That tells us that Z is a weaker reducing agent than M. So based on this information, the ranking is, practice makes perfect, so stop the video and try these two questions. For question 1, the answer is, lime is a base. For question 2, here's what's happening. In each reaction, hydrogen gas is produced, but calcium hydroxide is insoluble, whereas calcium chloride is soluble. And the first reaction is used to make lime. My silverware at home is plastic, so I don't deal with this issue. But if you have silverware at home, stop the video and read this statement and answer the questions. And the answers are, for part B, aluminum is more active than silver. And for part C, any metal more active than silver could be used. You probably have chlorine bleach at home. In lab, we're going to test chlorine bleach compared to bromine bleach compared to iodine bleach. Halogens are group 7 elements, and here's the order on the periodic table from top to bottom. We'll answer these questions in lab. Chlorine bleach is used as a disinfectant to kill bacteria. California recycles a lot of water each year. Here's how Orange County recycles and purifies their water. Although 70% of the earth is covered with water, not much of it is pure. So scientists have to figure out a way to purify water from different sources to meet the growing demand for water. One way to purify water is to use bacteria. Now, bottled water is expensive. Do the math. Unfortunately, we waste a lot of drinking water, and it's expensive to maintain our water infrastructure. So check out how much potable water we use and how much water it takes to make things. Peeing uses and contaminates water. Maybe waterless urinals are a solution. To meet the global need for waste sanitation, there was a Reinvent the Toilet challenge. Here's the criteria. A solar-powered toilet won the challenge, but there was a slight problem. Okay, so let's review. Stop the video and answer these questions. And the answers are: who has the better solution to prevent an iron pipe from rusting? Is it grandma or your high school chemistry teacher? Stop the video and answer the question. And the answer is because. Don't let this oxidation reduction reaction happen to you. Stop the video and fill in those 3 blanks. And the answers are: Coca-Cola is a very popular drink. Did you know it can also be used to remove rust? Stop the video and answer these questions. And the answers are: this is a double replacement reaction, which is not an oxidation reduction reaction. The reactions we've looked at so far go in one direction only. There are some reactions, however, which go not only in the forward direction, but also go in the reverse direction. Those reactions are called reversible reactions or equilibrium reactions. The reaction condition determines whether those equilibrium reactions go forward or backwards. We will cover equilibrium reactions in Chem 1B.